Hello and welcome to another video. This time I'm going to be doing the very first half of the Trig binomial differentiation and proof homework, the one which is prepping you for the test after half term. So let's have a little look at this then. What have we got here? Let's jump into the trig and binomial. That's what I'm going to do in this first little video. So first thing I notice about this, it's a proof, and it involves a little bit of double angle in there and a little bit of single angle over here, and apparently this all reduces to tan A. Now the advice I always give people when they're proving a trig identity like this is, if you're wondering which side to pick to work from first, go for the side which looks more complicated, because we tend to go from the complex to the simple in maths. We simplify, we don't complexify. So if I start with the left hand side here, I've got 2 over sine 2a minus, now I'm going to write this as, you've got a choice really, but I'm going to write it as cos A over sine A. I could write it as 1 over tan A, I really could, but the reason why I'm doing that is because on this side, I'm going to rewrite the bottom as 2 sine A cos A. I haven't really got much choice there. And so it's clear that I could kind of do with a sine A on there, because now I'm thinking, well, I want a common denominator, and the 2's over here are going to cancel. So if I times top and bottom here by cos A, then I've got a common denominator. So don't forget, the 2's are going to cancel here. So you're going to be left with 1 minus cos squared A over sine A cos A. And this won't be the only way to do this, definitely not. That's the same as sine squared. 1 minus cos squared is always sine squared over sine A cos A. And this equals, well, one of those signs cancels with the 1 on the bottom, leaving just sine A over cos A, which is tan A, which is the right-hand side. And we're done. So that first bit, not too bad. Honestly, proof of trig identities, provided it's not one of the really tough ones, it can often be really quite a nice question. Okay, so we're working in radians here, so I need to make sure my calculator's in radians. The other thing is, what do you spot between what we proved there and what we've got down here? Well, the angles are all double. So I'm going to have not, rather than having just theta here, I'm going to be, because I'm dealing with 4 theta and 2 theta, I'm going to need tan of 2 theta here, because obviously that is the same as that. So this is the same as tan 2 theta, because all that's happened is the angles have doubled. And so rather than being the same as A, it's going to be the same as 2 theta here. So tan 2 theta equals root 3. And so we need to arctan root 3, and that means that 2 theta is going to be, now inverse tan of root 3 is like 60 degrees in old money, but in radians it's going to be pi over 3. And you always add a pi when dealing with tan, so that's going to give us 4 pi over 3. And then at the end we can halve it, giving us pi over 6, or 2 pi over 3. Now, is 2/3 less than a half? No, it isn't, so we don't actually need that one. And so our only answer is theta equals pi over 3. That's for part 1. Pi over 6. That's for part 1. For part 2, how does this relate to it? Tan theta plus cot theta equals 5. Well, I suppose if we added the cot A over here, then we can say straight away 2 cosec. You see, I'm still using that result. 2 cosec 2 theta is going to be equal to 5. You see where I'm coming from there? Because if I added this over here, I'd be able to say that 2 cosec 2a is cot A plus tan A, or tan A plus cot A, if you like. And so that is the same as that, and so I can write that like that. Okay, so what am I going to have now? Well, this is 2 over sine 2 theta. So that it means that 2 is going to be equal to 5 sine 2 theta. Or in other words, sine 2 theta is 2/5. So 2 theta equals, well, we need to do inverse sine of 2/5. I'm just going to get my calculator out for this. Where are we? Let me just make sure I'm in degrees. Sorry, radians. See, it's so easy to make mistakes on these things, isn't it? Inverse sine of 0.4. Okay, I'm getting 0.411. But remember, whenever you do an inverse sine, or 0.412, I should say, let me make that a bit clearer. Whenever you do an inverse sine, cos, or tan, though, the very next thing you do is 180 minus, or in this case, pi minus your first answer when you're dealing with sine. And so that's going to give us 2.73. And then we're going to halve them. And we're going to get 0.206 and 1.37. Now, our answers to three significant figures there as well. Is 1.37 less than pi over 2? Yes, it is, because pi is about 3, so pi over 2 is about 1.5. And so we've got all our solutions there. So that was that one. That was the very first one. Not too bad. I don't think this one's too bad either, because hopefully you can recognize what we're really dealing with here is the compound angle for tan. If you've got tan A plus tan B over 1 minus tan A tan B, the formula book tells you that's the same as tan of A plus B. Yeah, it's kind of using this formula backwards. So what have I got here? I've got tan of 2x plus 50 is 2. And so 2x plus 50 is inverse tan of 2. Now we're in degrees here, so I'll have to keep changing. That's always a problem with these kinds of questions, isn't it? Change degree, change the radians, blah, blah, blah. Okay, inverse tan of 2, and we get 63.4. But whenever you do an inverse sin, cos, or tan, use the rules of thumb. So that's going to give you 243.4. We're going to be taking away 50 and dividing these by 2. I don't think we'll get any more than that in the range, but we'll have a little think about this in a second when we start making them. If I was to get another one, though, I just keep adding 180s. So add another 180 to that, you're going to get 423.4. Now, what are we doing? We're taking away 50 and then we're halving. So I'm just going to take away 50 from each of these and then halve. I think I get 6.72 here. Or 6.72, yep. And then I'm going to get 96.72 for this one. And then this one is just about in range, isn't it? Because when I do, I'm just checking it again, minus 50 on my calculator and then divide by 2, I end up with 186.7, which is in that range. So this is 186.72, and you've got all of your answers. You should really round all of these to 3 sig fig though. Oh no, sorry, it requested 2 decimal places, so we're good there. Okay, right, and the next one, the Ferris wheel one. I always quite like these r sine cos theta plus alpha ones. I like the modelling that they do. It's like kind of useful. Okay, so 10 cos theta minus 3 sine theta. We're going to try and write that in the form r cos theta plus alpha. Now, the way to do this, I mean, even if you can see straight away that r is going to be root 109, I agree it is. But in terms of like getting it absolutely spot on right, expand the right-hand side, you're going to get r cos theta cos alpha minus r sine theta sine alpha. Now, what can we see here? Let's use the little highlighter. We can see that 10 needs to be the same as r cos alpha. Let's write that down. 10 equals r cos alpha. And we can see that 3, not minus 3, but 3, because this has already got a minus behind it, is the same as r sine alpha. Now, what that's really telling you when you look at those two equations is that if this was alpha, well, as that's 3 over r is sine alpha, make the opposite 3 and the hypotenuse r. Likewise, cos alpha is 10 over r, so this makes a lot of sense when you look on the other side as well, because that's adjacent divided by hypotenuse. This is why r is always that squared plus that squared square rooted every single time. It's well worth knowing that. So 10 squared plus 3 squared, so that's going to be root 109. And to find alpha, you could just plug it into either one of those now, really. So, you know, alpha is inverse cos of 10 divided by root 109. Oh, it's getting a bit messy, my working here. And so alpha equals inverse cos. What mode are we in here? Degrees. I'm in the right mode. Inverse cos of 10 divided by root 109, 16.7 degrees. Okay, that is a basic technique. You definitely want to get good with that because it comes up all the time. Okay, so we've found r and alpha. And if you like, I'll quickly write it as 10 cos theta minus 3 sine theta equals root 109 cos of theta plus 16.7. Cool. Okay, what are we doing next? We've got a passenger, the height above ground on a passenger on a Ferris wheel is given by h equals 12 minus 10 cos 30t plus 3 sine 30t. Now, if you look, like they've actually, let's just write this down a little bit more clearly. 12 minus, if I was to change the sign here, I'd have pretty much what I just had. Yeah, I'm not really changing the sign, I'm just taking it out of the set of brackets to make it easier for my head to see what's going on. Okay, so clearly we can use part A. Yeah, and I'm going to straight away write down that h is the same as 12 minus, well, I wrote in a new format, didn't I? Root 109 cos theta plus 16.7. Yeah, that is so much easier to see what's going on because now if I want the maximum value predicted by this model, well, cos can be, it fluctuates between 1 and minus 1. So it could be as small, sorry, but excuse my yawning, I'm really tired at the moment. Cos could be as small as minus 1. And if you did 12 minus root 109, you get the maximum. So the max value, you can almost do it as a one marker in your head, is going to be 12 plus root 109. Give each answer 2 decimal places, so I'll just do that, 12 plus root 109. 22.4. 4. So that's the maximum height. Now the minimum height is actually going to be above ground because you obviously have some steps to walk out, I guess. But the value of t when the maximum occurs, well, normally cos has a minimum because we need cos to be minus 1 in this case. Like, so you can almost do this bit without a calculator. You could just set that equal to this equation and you could solve it. Yeah, you're well entitled to do that. But personally, I just think, well, I need this to be equal to minus 1. Yeah, save myself a little bit of time. So cos, oh, and we are not dealing with theta here, are we? We're dealing with 30t. So we've got a slight little transformation. Let me write down 30t in there. It's getting a bit messy. Let me see if I can just neaten it up a bit. 30t plus. There we go. So I need that to be equal to minus 1. Now, cos is at minus 1 when the argument is at 180 degrees. So I can say straight away, 180 is going to be equal to 30t plus 16.7. Now I can just rearrange to find the value of t by taking away 16.7 and dividing by 30. I'm just doing it on my calculator. Okay, I'm getting 5.44, and t is in minutes here, I think. Okay, hopefully that makes sense. Okay, part C. Calculate the value of t when the passenger is 18 metres above ground for the first time. Give your answer 2 decimal places. So this isn't too bad either because we can now just say 18 equals 12 minus root 109 cos of 30t plus 16.7. That's our equation which gets out of this, and now we've just got to find t. So take away that and then divide by root 109. You're going to get 18 minus 12 is 6. 6 over negative root 109 is going to be what I'm inverse cosing in a second. And so I'm going to get, right, let's do inverse cos of that. And you should be in degrees throughout this question because I believe the equation was in degrees. Okay, I'm getting 125.1 for 30t plus 16.7. Now you've got to be slightly careful here. It's got to be the first time. So yeah, it looks good because otherwise we'd have a negative value of t if I went negative. And this is definitely going to be positive. That eventually leads to take away the 16.7 and then divide by 30. And you get 3.61 for the first time it's above 18 meters. This is the interesting bit for me. Determine the time for the Ferris wheel to complete 2 revolutions. Now, you don't actually need to massively complicate this. Most of the time students do. Most of the time students do. There's no doubt about it. Let's just remind ourselves of the formula. It's 12 minus root 109 cos of 30t plus 16.7. Most students will massively overcomplicate this. They really will. But remember that this is just basically the cosine wave. Except that looks like sine wave. 1 second. cosine wave looks like that, and all we've done is we've stretched it, reflected it, and then moved it up 12, but it's still a wave, yeah? Now, what is a complete revolution here? Well, it's the time taken to go all the way down and all the way up again, yeah? And cos does that every 360 degrees, yeah? But that's if this is y equals cos x, yeah? If it was y equals cos 30x, then what does that do? Well, it squashes it by a factor of 30, yeah? So 360 divided by 30, this is going to complete this in 12, yeah? And that's why it's going to be, for 2 revolutions, 24 minutes, yeah? I can kind of do it in my head. I really can. You can just do, that's all you really need to do. Really, that is it. If you don't like that way of doing it, if you want to do it the long way, so I'm just telling you the answer is going to be 24 minutes, you can just consider the period of sine and cosine, how long it takes it to complete one whole wavelength, and then think about what the 30's done. Well, that's squashed out by a factor of 30. So it's just 360 divided by 30 is 12. That's for 1 revolution. Double it, you get 24 minutes. Okay, let's say you don't like that, because most of the time students don't. They really don't. Well, let's just pick two heights. Let's just say h is getting to 12, yeah? Let's find a time when it's at 12, and I think it's going to be at 12 when t is 0, which is handy, or somewhere similar to that anyway. Like, if you want 12 to equal 12 minus that, then clearly cos of 30t plus 16.7 is going to be equal to 0. And so 30t plus 16.7 is going to be equal to, now we're coming up to the important bit, inverse cos of 0 is pi over 2, or 90 degrees, yep. And so what other answer do you get there, though? You also get 270 degrees, yeah? Now, what we can do is just find the corresponding t values, because this one represents the first time you get 12 meters, and this one represents the second time you get 12 meters. There's nothing special about 12 here. I chose it quite arbitrarily because I knew I'd get some nice values, but you could have picked any constant height there, and then just found you could have put any number in you like, and then when you actually do the inverse cos bit and you find other answers, that's telling you the next time when it's at that corresponding height. And so you can use any height to work out how long it's going to take you to get to that height again, because that will be one complete revolution. So if I now take away 16.7 from both of those and divide by 30, so that's what I'm going to do, 19 minus 16.7 divided by 30, I get 2.44. And for 270, I'm doing it fully, 270 minus 16.7 divided by 30. Okay, I'm getting 8.44 there. Now, what has that told us? Now, as you can see, there's a gap of 6, yeah? 6 minutes. But is that one complete revolution? No, that's half a revolution, because the Ferris wheel is going round, yeah? And like, it's taking 6 minutes to go from like that height back to that height, but it's then got to go down and back up again. So therefore you need 12 minutes for one complete revolution, and you'll need 24 minutes for 2 complete revolutions. But by far the easier way of doing that is to just know the periodicity of sine and cosine. How long is the wavelength? Yeah, what is the wavelength there? It's 360 degrees. Well, not when you do that 30 squash. Yeah, that means all of a sudden it's 12 degrees long. In other words, 12 minutes long to complete, to go all the way down and all the way back up again. That's probably the easiest way to do it. So the final answer, 24 minutes. Come and see me if you think those ones are confusing. They are quite confusing when you first start doing them anyway. But it's a very common question, that. It's a very common question. Okay, let's go on to the binomial. Okay, with a binomial, what have we got here? Well, let's try and work out the value of a and b here and c. If we look at the left-hand side, what have we got? We've got 6 times by 9 plus ax squared to the power of minus a half. And that's going to roughly equal 6 times. And I'm just going to work out the first 4 terms. So, okay, what have I got? I've got 1 plus n times by x. So that's going to be minus a half ax squared. Plus, okay, now what we're going to have now, we're going to have minus a half. Oh, hang on, what am I doing? What am I doing? I need to sort out this 9 here. My God, that was terrible. I just suddenly noticed a 9. Okay, if you've got this, you've got to fiddle around first. There is actually another cunning way you can do it, but I won't confuse you by going through that in this video. Let's divide everything by 9 first. But remember, we're going to have to put 9 to the power of minus a half as well here. And that's going to give me 6 times. Now, if 9's been put to the power of minus half, that means square it and put a 1 over it. So that's going to be 6 times a third times by 1 plus ax squared over 9 to the power of minus a half. Now I'm in a position to use the formula. We're going to get 2, open bracket, 1 plus minus a half times by ax squared over 9 plus minus a half times minus 3 over 2 times by ax squared over 9 squared all over 2 factorial. So I've done n times n minus 1 times ax squared over 9 plus 2 factorial, yeah? And now let's multiply out and simplify this. We get 2. So it looks like b might be 2. Then we're going to get minus ax squared over 9 plus, now don't forget to double this bit. I'll do it by just doubling away the factorial, I think. Then I'm going to get 3/4 multiplied by a squared x to the 4 over 81. And I think I've got everything right there. Okay, so what do we have here? Well, by the look of it, bearing in mind this is supposed to equal b minus 2/3 x squared plus cx to the 4, we should be able to work everything out now. By inspection, b equals 2. A over 9 is going to be equal to 2 over 3. So I guess A is 6. And then finally, if we work this out, we're going to get 36, 3/4 of 36 is 27. 27 over 81 is like 3/4, isn't it? So 3/4 x to the 4 equals cx to the 4. So it looks like c is 3/4. Now let me just check that because I rushed that last bit there. I'm feeling a bit dizzy actually, I don't know why. Need to get out of the shed. Right, let's just go through that last bit again. 3/4 times by a squared, which is 36 x to the 4 over 81 is going to be equal to c x to the 4. Well, let me just check I've got everything as I should be having there. 6 squared is 36. Yep, that looks good to me. Okay, so 3/4 of 36 is 27. Hang on, 27 over 81 is a third. So C is a third. I've just seen that, sorry. 3/4 of 36 is 27. 27 over 81 is 1 over 3, yeah. God, getting dizzy today. So that's A, B, and C there. Hence, find the coefficient of x to the 6. Oh my God, we're going to have to go further. We're going to have to go further. So you're probably going to hear my kids screaming in a minute because they're just banging on the shed. They want me to push them on the swing. Hang on, Ollie. Right, okay, right, what we got here? Coefficient of x to the 6. Well, you're going to have minus a half times minus 3 over 2. Oh, getting ahead of myself. Times minus 5 over 2. Finish that bracket off. Times by ax squared over 9. Might as well write a in a 6 actually. And 6 over 9 is 2 over 3. So 2/3 x squared. And that's going to be going to the power of 4 this time. Oh, sorry, power of 3. Beg your pardon. We're going to be putting that over 3 factorial. Okay, what does that come to? Well, let's have a look at this. We're going to have that 3 cancelling with that 3 leaving just a 2 on the bottom. Then we've got 5 over 8, 5 over 16, multiplied by 2/3 cubed is 8 over 27, multiplied by x to the power of 3 times 2, which is 6. And so what does that come to? Let's work that out. 8 over 16. Oh, and it's going to be negative. Yeah. And have I missed anything there? 2, 4, 8, 16. That looks good. just checking everything, all the bits. So the problem with these questions is it's so easy to miss something. Oh, there's this times by 2 at the start, isn't there? So I do actually need to still double it. It's all getting doubled because of the 2 which is lurking there outside the brackets. And so I think as that 2 will make that 8 a 16, I think it's minus 5 over 27. Can I just check that with the mark scheme I've got over here? 1 second. I've got it on my other monitor. Yep, that's right now, minus 5 over 27. Okay, so let's have a look at the next one. What have we got here? Use the binomial expansion in ascending powers of x to expand that to show that that equals that. Show that question. So much nicer when you know what the answer is, isn't it? You can always fix your sign errors then. Okay, so let's just consider this expansion first. So if I was expanding 1 minus 2x to the minus a half, at least I can basically do that in one go. We're going up to just x squared here, just the third term. So that's going to be 1 plus minus a half times minus 2x plus minus a half times minus 3 over 2 times by minus 2x all squared. So let's just simplify that. 1 plus x, that's going to be 3/4, but you're going to be timesing it by 4, so plus 3x squared. Now they want to know what happens when you multiply this by 2 plus 3x. Well, if we've got that, then I guess we're going to need to do that times by 2 plus 3x. But that equals 1 plus x plus 3x squared. And I can ignore the rest of the expansion because I only care about the first few terms. And the next few terms aren't going to interfere with the first terms when they're ascending powers of x. I can't even write now. Okay, let's times it all by 2. And then let's times it all by 3x. But let's ignore the last term because it's going to be cubed. What do we get? 2 plus 5x plus 9x squared. Slightly disappointing because we've got here 2 plus 5x plus 6x squared. So let's find where we went wrong. Probably rushing it somewhere up here. That's 3/4 times by 4. That is going to be 3x squared. I agree with that. I think. Yep. And then I'm timesing this all by 2. Times it all by 2. And then I'm timesing it all by 3x. So it's as if the 3x squared is wrong. I'm just desperately checking this now. 4x squared. Where have I gone wrong? Minus a half times minus 3 over 2. Oh, yeah, I forgot to divide by 2 factorial, didn't I? Idiot. Okay, and that makes that 3 over 2x squared. I'm getting slightly put off because there's one of my kids assaulting the shed door trying to see me. Okay, so I've got 1 plus x plus 3 over 2x squared. That's going to be over 2. That means that when I times it all by 2, that's actually going to be a 3. It's nice there when they show that though, isn't it? And then this one times this one is actually going to be a 3x squared as well. It's now going to work out nice. And it works out to what they said it would do. 2 plus 5x plus 6x squared. Lovely. Okay, right, last little bit. Substitute x equals 1/20th into this to obtain an approximation to root 10. Right, firstly, whenever you're doing these questions, ask yourself why it will give you an approximation to root 10. Yeah? Here's my question. Why? Why does this work? So I'm going to look at the left-hand side. Yeah? So 2 plus 3/20 divided by root of 1 minus, right, 2 over 20 is 1 over 10. And so this is actually going to be, well, by the look of it, that's going to be that's 43 over 20 divided by, right, 1 minus 1 over 10 is 9 over 10. So it's the square root of 9 over 10. Well, this is the same as 43 over 20 divided by, square root of 9 is 3 over root 10. And so what does this equal? This equals 43 over 20 times by root 10 over 3. And that's going to be 43 over 60 times root 10. Yeah? Now, What an ugly one to use to actually, like, you know, what an ugly result. What it means is, after we plug this in here, that's going to find us 43/60ths of root 10, and therefore I'm going to have to times it by 60 and then divide by 43 to find an approximation for root 10. Sorry, my kids are screaming now outside. Okay, right, how am I going to do that? Well, let's just plug in x equals 1/20th into here. We get 2 plus 5 over 20 plus 6 times 1 over 20 squared. You can use a calculator for this, but I think it gives you, well, I'm going to use a calculator as well, actually. 2.25 plus 6 times by 0.05 squared. Okay, I get 453 over 200. So root 10 is going to be roughly equal to 60 over 43 times by 453 over 20. And I'm just going to times that by 60 divided by 43. Okay, I'm getting 1359 over 430. And that's it. So yeah, look out for that. Students often don't realise, they just assume that this is just going to give you a smashing approximation for root 10. Check, it's actually normally just a multiple of root 10. And as you can see here, it's actually quite an ugly multiple of root 10. Okay, that was the first half of the homework. Hope it was useful. I'll post up the next half of the homework very, very soon. Keep up the hard work, everybody. You can do it in the test. You can do it. Bye-bye.